Hello, welcome to GT Sport. MotoGP, the pinnacle of motorcycle racing, is not just a contest of speed, but also a celebration of technology, engineering, and skill. It represents the fusion of the most advanced developments in motorcycling with the incredible bravery and expertise of the riders. At the heart of MotoGP is speed, an element that has been relentlessly pursued and refined throughout the sport's long history. However, achieving speed is not simply about raw horsepower. It's about creating a machine that can manage that power while ensuring stability, control, and performance. In this exploration, we will dive deep into the evolution of MotoGP, focusing on how motorcycles have progressed in terms of speed, precision, and technological sophistication. The humble origins, a simpler time. MotoGP began as a simple motorcycle race long before the advanced machines we see today. In its early years, the sport was more about endurance and stamina than outright speed. The motorcycles of the early days were basic machines with limited technological features. Speed, while important, was not as developed or refined as it is now. The first motorcycles were often more about durability and reliability, with engines that could run for hours without breaking down, rather than engines designed for blistering top speeds. Racing was a test of not just the machine, but also the rider's ability to maintain their stamina and endure long hours on the track. At this point, the designs were rudimentary, with little thought given to aerodynamics or advanced materials. Speed was still in its infancy, and the most crucial factor was simply getting through the race, rather than attempting to break speed records. The transition: more power, more speed. As the sport grew and technology progressed, the 1970s and 1980s marks the beginning of a major shift in MotoGP. With the increase in competition, manufacturers started to focus more on the performance aspects of their bikes, aiming to achieve faster lap times and greater speeds. The bikes were still quite rudimentary compared to today's standards, but significant improvements were being made in both engine performance and design. During this period, manufacturers introduced more powerful engines and began experimenting with different configurations to gain an edge. The focus was not just on engine size, but on how the bike could be made faster, more agile, and better suited to the increasingly challenging tracks. This era also saw the introduction of innovations such as more advanced suspension systems and lightweight materials, which paved the way for the next generation of motorcycles. Speed, once seen as a secondary concern, was now becoming a central focus of the sport. The race was no longer just about endurance, but about pushing the limits of performance. The speeds achieved on the track were growing steadily, and motorcycles were becoming faster, more responsive, and more durable. The rise of the modern era: precision and control. By the 1990s, the sport was witnessing a massive technological leap. The introduction of four-stroke engines was a pivotal moment in MotoGP history. Four-stroke engines offered greater efficiency, more torque, and better fuel management compared to their two-stroke counterparts. This change significantly impacted both the performance and durability of the bikes, allowing them to reach higher speeds while maintaining reliability. With the rise of four-stroke engines, the focus shifted to not just achieving top speeds, but also achieving greater precision in control. Engineers realized that speed alone was not enough. To achieve true dominance on the track, motorcycles had to be finely tuned for every type of corner, braking zone, and acceleration. This period marked the introduction of advanced suspension systems that could be adjusted based on the specific needs of each track. With better control over the suspension, riders were able to take corners with more precision, maximizing both speed and handling. During this time, aerodynamics also started to play a more prominent role in motorcycle design. The goal was not just to go fast in a straight line, but to reduce drag and ensure the bike remained stable at high speeds. The introduction of more streamlined bodywork and fairings allowed motorcycles to cut through the air more efficiently, reducing drag and improving top speed. In tandem with these advancements, engineers began experimenting with materials like carbon fiber and titanium to reduce the weight of the bikes, making them quicker and more agile. The technological arms race: speed and innovation. The 2000s saw a technological arms race between manufacturers, each striving to develop the fastest, most sophisticated machine possible. This era marked the widespread introduction of electronics into MotoGP. Advanced systems such as electronic fuel injection, EFI, traction control, and advanced data logging began to revolutionize how the bikes were managed on the track. Electronic systems played a crucial role in allowing riders to maintain control over the enormous power generated by the engines. These systems help manage throttle response, reduce wheel spin, and optimize power delivery, particularly in challenging conditions. The electronic systems also allowed for smoother gear shifts, enabling the rider to accelerate without losing momentum, even under intense pressure. The development of seamless gearboxes was another breakthrough during this period. The ability to shift gears smoothly and without interrupting power delivery helped riders maintain their speed and performance. This technology allowed for faster acceleration and more consistent lap times, further enhancing the competitive edge of the sport. Aerodynamics also reached new heights. The design of the fairings became more complex, with new innovations aimed at generating downforce and improving stability. This period saw the introduction of winglets and other aerodynamic components designed to keep the bike stable at high speeds, especially during braking and acceleration. While initially controversial, these innovations became essential in maintaining the bike's performance and stability on the track. The modern era: precision, speed, and smart engineering. In recent years, the evolution of MotoGP motorcycles has been defined by the seamless integration of precision engineering, powerful engines, and sophisticated electronics. Modern motorcycles are now capable of achieving speeds in excess of 350 kilometers per hour, 217 miles per hour, a remarkable feat of engineering that reflects the continuous innovation in the sport. The engines of modern MotoGP bikes are masterpieces of performance, pushing the limits of what is possible with internal combustion. These bikes now use highly advanced fuel management systems, which ensure optimal power delivery across a wide range of conditions. The level of control offered by modern electronics is unparalleled, allowing riders to fine-tune their machines in real time to adapt to the changing conditions of each race. Aerodynamics has continued to evolve, with bikes now featuring complex aerodynamic elements designed to reduce drag while increasing downforce. The introduction of more advanced winglets and bodywork continues to improve the bike's stability at high speeds, allowing riders to maintain control in the most demanding conditions. The integration of advanced data analytics has also become a critical factor in the development of modern motorcycles. Now, engineers collect vast amounts of data during practice sessions and races, using this information to refine the performance of the bikes. This data-driven approach has allowed manufacturers to continually improve their bikes, ensuring they remain at the cutting edge of technology. The future of MotoGP towards sustainable innovation. Looking towards the future, the evolution of MotoGP is far from over. With the rise of electric and hybrid technologies, there is a growing focus on creating sustainable motorcycles that can perform at the highest level without compromising on power and speed. The shift towards more environmentally friendly technologies, such as electric engines and energy recovery systems, promises to change the landscape of the sport while maintaining the excitement and intensity that fans love. In addition to sustainability, the future of MotoGP will likely see even more advanced developments in aerodynamics, materials, and electronics. New materials such as graphene and advanced composites are being explored for their potential to reduce weight and improve performance. Meanwhile, artificial intelligence and machine learning will likely play a larger role in optimizing bike performance in real time, offering even more precise control over every aspect of the motorcycle's behavior. While the motorcycles of tomorrow may look and feel different, one thing is certain: the pursuit of speed, precision, and technological excellence will remain at the heart of MotoGP. The machines that race on the track today are a testament to the extraordinary achievements of the past, and they will continue to pave the way for the future of racing. A legacy of speed, precision, and innovation. MotoGP's evolution from its humble beginnings to the technological marvels we see today is a story of relentless innovation. From the raw power of early engines to the sophisticated data-driven machines of today, the sport has continually pushed the boundaries of what is possible in the world of motorcycle racing. Every new development, whether in engine design, aerodynamics, or electronics, has contributed to the creation of faster, safer, and more precise motorcycles. As the sport continues to evolve, the legacy of MotoGP will undoubtedly continue to inspire future generations of engineers, riders, and fans. MotoGP is more than just a race. It's a celebration of human ingenuity, a pursuit of speed, and an ongoing quest for perfection. The machines that race on the track today are a testament to the extraordinary achievements of the past, and they will continue to pave the way for the future of racing.
As we look to the future of MotoGP, it's clear that the sport will not only embrace new technologies, but will also continue to challenge the very limits of what is possible. With the rise of autonomous systems and AI-driven analytics, MotoGP bikes could one day adjust to conditions in real time, making decisions faster than any human rider could. This level of sophistication will allow for even more refined performance tuning, where every variable, temperature, humidity, tire wear, fuel levels, will be factored into the bike's performance dynamically. The integration of virtual reality and simulation tools will further enhance training, allowing riders to perfect their skills in controlled, virtual environments before facing the challenges of real-world racing. Moreover, the growing emphasis on sustainability could usher in a new era of MotoGP where electric and hybrid engines take center stage. As manufacturers strive to reduce the sport's carbon footprint, we may witness the introduction of fully electric races that retain the speed and excitement of traditional MotoGP while adhering to the principles of environmental responsibility. Thanks for watching, and see you in the next video.